You're an adult, standing in your kitchen, pouring a glass of milk. You drink it. Nothing happens. No cramps, no bloating, nothing. You've done this your whole life without a second thought. Here's the strange part. Biologically, that glass of milk should be making you sick. Every mammal on Earth is born with the ability to digest milk. That's the whole point of being a mammal. But every mammal, without exception, is also programmed to shut that ability off after weaning. Once you stop nursing, the gene that produces lactase, the enzyme that breaks down milk sugar, gets switched off for good. That's not a flaw. That's the default setting for every mammal that has ever lived, including every human being who was ever born more than 10,000 years ago. If you can drink milk as an adult without getting sick, you are not normal by mammal standards. You are a mutant. And so is most of the population reading this in Europe, the Middle East, and parts of Africa. So here's the question this video is built around. If shutting off that gene is the default for every mammal on the planet, why did a chunk of humanity evolve to keep it running? And more importantly, who actually benefited when that happened? You, or the animal whose milk you were drinking? Let's start with what should not be possible. Geneticists have traced the ability to digest lactose into adulthood to a tiny mutation, a single change in your genetic code sitting near the lactase gene. That one mutation is enough to jam the off switch. Instead of shutting down after childhood, the gene just keeps running for life. And here's the part that should really stop you. This exact fix didn't happen just once. It evolved independently in at least 5 separate human populations, in Europe, in the Middle East, and in different parts of Africa, each one using a different mutation to land on the exact same outcome. That's not a lucky accident happening once. That's evolution solving the same problem over and over again in populations that never had any contact with each other because the pressure to solve it was that strong everywhere it showed up. What made that pressure so strong comes down to what milk actually offered. Before dairying, milk past infancy simply wasn't on the menu, biologically speaking. The moment a mutation let someone's body keep processing it into adulthood, that person suddenly had a steady supply of protein, fat, and calcium that the non-mutants around them couldn't touch. In communities that depended heavily on herding, that advantage may have gone even deeper than nutrition. Some researchers argue this mutation spread as fast as it did because it improved a mother's odds of surviving childbirth and raising healthy children, not because it made anyone taller or stronger. That part is still debated among geneticists, but if there's truth to it, this one tiny genetic switch may have quietly decided whose family line continued and whose didn't. In places where milk wasn't a luxury, it was survival. None of this is just theory built on guesswork either. Researchers analyzing ancient pottery from Neolithic Europe found actual milk protein residue baked directly into the clay, dated to around 7,000 years ago, in the exact regions where this mutation later became common. Ancient DNA and ancient kitchenware, 2 completely different kinds of evidence, are telling the same story from 2 different directions. Here's the twist that turns this from a simple success story into something stranger. If dairying is really what drove this mutation, you'd expect every culture that raised dairy animals to have it. They don't. Researchers studying herding populations in Central Asia, communities that have depended on milk from cows, sheep, and horses for thousands of years, found that most of them are still lactase non-persistent as adults. They drink milk anyway, mostly turned into fermented yogurt and cheese, which lowers the lactose content just enough for their bodies to handle it without needing the mutation at all. So the mutation was never a requirement for using dairy. It was an optional shortcut. Some populations solved the same problem culturally, fermenting milk into cheese and yogurt, and simply never needed their DNA to change. Others, for reasons still being debated, ended up rewriting their own genetic code instead. Which brings us back to the real question: who won this deal? If you're one of the people who can drink a glass of milk today with no problem, you're carrying a genetic trophy that took thousands of years of selection, pressure to build, purely so that a food source belonging to another species could become permanently available to you. But flip it around. That gene didn't spread because milk needed you. Milk isn't trying to reproduce, and it isn't competing for anything. What actually spread was a herding culture, cows, goats, and sheep that depend entirely on humans for food, shelter, and protection in exchange for a product humans could now digest for life. The animals got permanent caretakers. Your genome got permanently rewritten to make that arrangement more profitable for everyone involved, all at once. There's no clean villain in this one, no grass quietly running a con the way wheat did. This looks more like a trade that both sides needed badly enough that biology itself changed just to keep it running smoothly. So here's the real question to leave you with. Every time you pour a glass of milk without thinking twice, you're using a mutation that rewired your own species specifically to keep a farming relationship with another animal running smoothly. What other habits in your life might actually be the visible tip of some much older arrangement, one your body or your behavior quietly adapted around long before you ever had a say in it?